Page 79. Side splitter theorem and angle bisector theorem. Right, we're not going to prove these theorems today, the side splitter theorem and the angle bisector theorem, but we are going to start to use them. When we get into proofs next week, one of our jobs will be to prove these two theorems. So I will explain the why of how these work in class tomorrow, but I just want to show you what the theorems are and how we're going to use them. Okay? So again, our objective is to determine missing lengths using scale factors and ratios. So the side splitter theorem. Okay, so here's the side splitter theorem. When three or more lines are parallel, and two transversals intersect the lines. I'm going to leave some space here because we're going to draw a picture of this in a minute after we get done writing it. Then the parallel lines partition, that means cut the segments into equal proportions. So what this means is if I have three parallel lines, parallel L, parallel M, and parallel N, okay, and two transversals, these two segments are going to be in the same proportion as these two segments. So if these are 4, the segment right here is 4, and the segment right here is 5, then these two segments are going to be in the same proportion. So if this one was 8, the proportion is 4 to 5. Well, x, if I was trying to find x, I would set up my proportion. 4 to 5 is going to be in the same proportion as 8 to x. Cross multiply, I get 4x equals 40. So x is 10. Okay? So this side splitter theorem comes in handy in a particular diagram. Okay? So our first example, and I'll show you two examples before we solve them, is an example with a triangle. So what I want you to do is I want you to pause the video right now. Wait, I mean, like, don't actually, wait, back up. I want you to find x and y and both problems, then pause the video. Okay, so take a minute, pause the video, complete these two problems. Have you paused the video? Did you actually do the work? I hope so, because I'm about to show you what it is. Okay, so what your work should look like is these two sections should be in proportion, because really I have a third parallel line up here. Okay, and I'm going to use this third parallel line to use a side splitter theorem. So 10 over 8, or 8 over 10, should be in the same proportion as 20 over x. So again, I'll cross multiply, and I will get x is 25. Okay.
Dawson, Burlingame, please come to the guidance office. Dawson, Burlingame, please come to the guidance office.
So now I'm going to find x again, and I know that 2 over x should be in the same proportion as 10 over 15. So again, I'll cross multiply. And if I want to find y, again, this is 3. 3 over 15 should be in the same proportion as 5 over y. So y is 25. Okay? So this is the same idea as what we were doing yesterday. I'm still setting up proportions. I'm just using this new idea of the side splitter theorem. There's one other theorem that we need to know. And this one, you're not going to believe me that this is true. And I'll explain why this is true in class. But I just want to keep the video short for today. Okay? So the other theorem is the angle bisector theorem. What the angle bisector theorem says, it says take any triangle and draw a ray that bisects the angle at the top. I don't really like the picture of this triangle. I'm going to draw a different triangle. Ready? Okay. Take any triangle. There we go. That's a better one. Draw a ray that bisects the angle. Okay. Now what the angle bisector theorem says if ray BD bisects angle B, then AB over BC will be in the same proportion as AD over DC. So what that means, if I know that AB is 8 and BC is 10, and AD is 4, and DC is x, I don't know what x is, I can set up a proportion using these two sides that will be in the same proportion as these two segments. Okay? So 8 over 10 will be in the same proportion as 4 over x. So when I cross multiply, I get 8x equals 40, x is 5. Okay? And you're not going to believe me on this one, but let me tell you, it works. Okay? And we'll discuss why it works in class. It seems really weird, but essentially these two sides will be in proportion, and it's the same proportion as these two sides are in. It's bizarre. We'll talk about it in class, but it works. All right, that is it. Talk to you later.